Civil engineering and BIM teams do not only manage drawings, they manage data about terrain, quantities, alignments, utilities, drainage, structures, phases, permits, risks, and cost. The challenge is that this data often lives in different tools and formats. One person has the model, another has the spreadsheet, another has the site report, another has the consultant email. In this video, we look at AI agents for BIM and civil engineering, how they can help turn scattered project data into clearer decisions, while keeping engineers responsible for final technical judgment.
A BIM or civil engineering agent is not a magic engineer. It is a workflow assistant that can read, organize, compare, and route information. It can summarize model exports, check schedules, explain changes, draft coordination notes, or prepare a quantity review checklist. The most useful agent workflows are not the ones that claim to design a bridge by themselves. They are the ones that help professionals catch missing data, compare assumptions, and prepare better questions before a coordination meeting.
The first use case is quantity and schedule review. Civil projects often generate long spreadsheets, earthwork volumes, pipe lengths, pavement areas, rebar quantities, concrete volumes, drainage structures, signage, lighting, and utilities. A human can review these, but it is easy to miss an outlier. An AI assistant can help analyze exported data and flag suspicious rows. For example, one road segment may show double the expected excavation volume, one pipe size may be missing, or one structure may appear in the drawing list but not in the quantity table.
This is not about trusting AI with cost control. It is about reducing the review surface. Instead of asking an engineer to stare at 1,000 rows, the assistant produces a short list of questions. Why does section C have no drainage item? Why does the retaining wall length change between issues? Why is the unit label inconsistent? The engineer then checks the model, the drawings, and the measurement method. The AI helps create a first-pass audit trail.
The second use case is coordination. Civil projects are full of conflicts. Underground utilities, drainage slopes, road profiles, foundations, landscape grades, lighting poles, traffic equipment, and building connections. BIM coordination tools can detect geometric clashes, but many coordination problems are also textual or procedural. A note in a meeting says a utility must remain active. A drawing revision moves an access road. A permit condition restricts work hours. An AI agent can help connect these notes to the relevant model zones and coordination topics.
Imagine preparing for a weekly coordination meeting. The agent reads the last meeting notes, RFI log, submittal log, and exported clash report. It produces a short agenda: unresolved utility conflicts, drainage decision needed, structural interface pending, survey data update required, and client approval risk. The meeting becomes less about remembering what happened and more about deciding what happens next. That is the real productivity gain.
The third use case is revision explanation. In infrastructure projects, a small model change can affect many downstream documents. A road level changes, then drainage invert levels change, then quantities change, then a permit drawing must be updated. AI can help draft a change summary if you provide the right inputs, revision notes, exported schedules, affected sheets, and a short project description. It can produce a human-readable explanation: what changed, why it changed, which packages may be affected, and what needs verification.
This is valuable because not every stakeholder reads BIM data directly. A client, contractor, or permit reviewer may need plain language. The AI can translate technical changes into a clear narrative, but the engineer must confirm the technical accuracy. A good change summary says, based on the supplied revision log, not the model is correct. That wording matters. It keeps the assistant honest about its source.
The fourth use case is calculation preparation. Civil and structural calculations require professional competence and often licensed responsibility. AI should not be treated as the engineer of record. but it can help prepare inputs, create checklists, and organize assumptions. For drainage, it can list the catchments that need review, missing rainfall assumptions, pipe sections requiring slope confirmation, or places where the units may be inconsistent. For structures, it can help organize load cases, material assumptions, and drawing references for human review.
The safest framing is this: AI can help before and after engineering judgment. Before, it gathers inputs and identifies missing information. After, it helps explain the decision and create documentation. The actual engineering decision stays with qualified professionals using validated methods, software, and standards. This is not a weakness of AI. It is how responsible practice works.
A practical first workflow is an exported schedule checker. Export a table from your BIM or Civil tool. Ask the AI to inspect it for blanks, duplicate IDs, inconsistent units, unusual values, and rows that need review. Then keep the output as a QA note. Later, Codex can help turn that review into a repeatable script. N8N can trigger it when a file lands in a folder. OC can store the results, but the first version should be simple enough that the team trusts it.
Data culture is the foundation. If your model parameters are inconsistent, the AI cannot save you. If file names are chaotic, automation becomes fragile. If nobody owns the review process, summaries become noise. AI agents reward teams that define standards clearly. That means naming rules, parameter rules, issue logs, revision logs, and responsibility matrices. The better your project data, the more useful your AI workflows become.
A strong BIM or Civil AI workflow starts with a data standard. Every exported table should show the source model, export date, units, coordinate or station reference, revision, and reviewer. Every object or item should have a stable ID. Every quantity should have a measurement basis. Without these basics, the AI may still produce a polished summary, but the summary will rest on weak data. In engineering, polished weak data is dangerous because it looks more reliable than it is.
For a pilot, choose one dataset that the team already understands. A drainage structure schedule is a good candidate. A road sign schedule, door schedule, room schedule, or quantity table can also work. Ask the AI to identify blanks, duplicates, unit inconsistencies, unusual values, and missing references. Then have the responsible engineer or BIM lead mark each finding as valid, false alarm, or needs more information. That feedback becomes the training material for your office workflow.
Over time, the agent can produce trend reports. Which kinds of errors repeat? Which consultants send incomplete data? Which model parameters cause confusion? Which review comments appear every issue? This is how AI becomes more than a checker. It becomes a mirror for your production process.
For civil teams, that mirror is valuable because coordination problems often repeat quietly. The same unclear station reference, the same inconsistent unit, or the same missing asset ID can travel through several submissions. A monthly AI-assisted QA review can show the pattern before it becomes normal. The team can then update templates, training, and model requirements. That is a better use of AI than asking it to guess engineering answers from incomplete data.
If the team improves the standard after every issue, the model becomes cleaner, the review becomes faster, and the project record becomes easier to defend.
That is a measurable engineering productivity gain, not a vague AI promise.
To recap, BIM and civil engineering agents can help review quantities, prepare coordination agendas, summarize revisions, and organize calculation inputs. They should not replace engineering responsibility. They should reduce noise and help professionals focus on the decisions that matter. If you want more practical AI workflows for BIM, infrastructure, architecture, and construction, subscribe, like this video, and comment with the civil or BIM data task your team struggles with most.